Hello, this is the luckiest maths teacher in the world. Thank you so much for tuning into this video in which we'll look at actually calculating the area between two curves. So this is the kind of question you need to be able to do. We're given two curves here and we're asked to calculate the area bounded by them, which is the same as saying the area between these two curves. So this question is a little challenging because it doesn't tell us which function is on top, and we also don't know the x values between which we're integrating. Are we integrating between x equals minus 10 and 10 or x equals minus 230? We don't know that. What we need to do first in this example is we need to find the points of intersection. So you can use your graphics calculator for that or do it by hand. So I'll just do this one by hand because it's pretty simple and just to show you in case you're stuck somewhere and you need to do it by hand. So if you have two curves in the form y equals, so you just equate them. So first curve is equal to second curve. This will allow us to find the points of intersection. So we're going to make one side equal to 0. That will enable us to use the null factor law. And now we're going to factorize. So all three terms, 1, 2, 3, have a common factor of x. So I'll take that out. So then I get x squared minus x minus 2. So hopefully you've done it a million times and you remember how I factorize this. It's a monic quadratic trinomial because it has three terms. And so I find two numbers that multiply to this, minus 2, and add to this. So the two numbers that multiply to minus 2 and add to minus 1 are minus 2 and 1. So then null factor law says either the first thing equals 0, the second bracket equals 0, or the third bracket equals 0. So the points of intersection, these curves intersect actually at 3 points, when x equals 0, 2, and minus 1. So we can use our graphics calculator to see which function is on top. This is what the graphs would look like. So this is what the graphs look like. Again, you can use your graphics calculator to help you get your bearings. So really what we're calculating is this area in here plus this area in here. That's the area between the two curves. So as you know from a previous video, we're going to need to do two separate integrals. So for this first area here, it's the red function that's on top, and that occurs between x equals minus 1 and x equals 0. So red function goes first, and then I subtract the second function. Okay, and you should write the dx, but I don't think it's that big a deal. So then we're going to add the area in the second region. So this area here, this time the blue function's on top. So that goes between x equals 0 and x equals 2, and it will be x squared plus 2x, and this time we're subtracting x cubed because it's on the bottom, and I'll just put the dx in there. So let's just figure out these two definite integrals. So for the first one, integral of x cubed is x to the power of 4 on 4. So this becomes minus x squared minus 2x. So the integral of minus x squared is minus x cubed on 3. And the integral of minus 2x is minus x squared. Remember, definite integrals, no constant of integration. We evaluate it between 0 and minus 1. And now I'm going to do the second one. This time it will be x cubed on 3. And the integral of 2x this time will be positive x squared minus x to the power of 4 on 4. And we're going to evaluate that between 0 and 2. So let's deal with this one here. If I substitute in x equals 0, I just get 0. So then I minus. Now substituting in x equals minus 1, you need to put brackets around it because otherwise you get the wrong answer. So I get 1/4. This becomes a positive plus a third minus 1. So then looking at this one here, so substituting in x equals 2, so I would get 8 over 3 plus 4 minus 16 over 4, which is also 4. And if I substitute x equals 0, I just get 0. So what I end up with is 5 over 12 plus 8 over 3. So that just gives me 37 over 12, or 3 1/12, 3.083 units squared. So there was a bit of work in this because you do need to make sure you know where the points of intersection are, and you also need to know which function is on top, and then we just use our formula, the definite integral between the two intersection values of the function on top minus the function on the bottom. All right, thank you so much for tuning into this video. This has been the luckiest maths teacher in the world. Have a great day.